Alright, today we're doing 9.6, we're doing dilations. And just as we realized in class, B and D are our dilations, and A and C are not. And I know what you're thinking, right? Dilations are something when they're getting bigger or smaller. And sure, A and C are getting bigger or smaller. Well, the only problem is we have to remember that word proportionally. Way down here at the bottom of the page where the definition is located. Dilation enlarges or reduces dimensions proportionally. So it's going to look like the same picture, like B here looks like the same picture, just smaller. And the same thing with D. But then clearly C does not and A does not. We're also going to use those fancy terms, enlargement and reduction. So enlargement when it's getting bigger, reduction when it's getting smaller. And notice that number 1 right here. So an enlargement is when it's greater than 1, that scale factor, and then a reduction is when that scale factor is greater than 0, of course, but less than 1. So, of course, bigger than 1 getting larger, less than 1 getting smaller. That's on the next slide. Let's look at that scale factor. Alright, like previous examples, I've taken the liberty of graphing our first picture, so our first triangle here with these coordinates right here, the same ones are listed right here a little smaller so we can show some work. And that's our picture. Here's that scale factor. And we notice first off, right, the scale factor is 1/2, which is less than 1. So in our heads we need to think this new picture better be smaller. Less than 1 means a reduction. New picture better be getting smaller. So how do we do it? Not too bad. Here we go. We take our 1/2 and we change that to a decimal. Makes it a little easier for us, and we're just going to say, hey, you know what? 1/2 is 0.5. And all we're going to do is take our 0.5. We're actually going to multiply each of these guys over here by 0.5. So -4 times 0.5, -2. 4 times 0.5, 2. Those are our new coordinates. Shrink this guy a tiny bit, give us some room. So we have what? Our new P prime. There it is. -2 and 2. We have our Q prime. And we multiply by 0.5. 0.5. Right. -2 times 0.5, -1. -2 times 0.5, -1. There's our Q prime. Move this guy over a bit so I can use some work. So what do we have? The new guy is R prime. Right, that new R prime always, little apostrophe looking thing there. So we have, get that guy out of the way a little bit. R prime. So we have what, 0.5 right here, 0.5 right there. So we have 4 times 0.5, 2. 0 times 0.5, 0. Those are our new coordinates. All you have to do, take your new coordinates, plot them on the graph. So, -2, 2, P prime. -2, 2, P prime puts us right here. We're going to write that and label that, right? P prime. -1, 1, -1, there we go. That guy is Q prime. And then 2 and 0 is our R prime. Connect our dots. And we have our shape that is proportionally smaller, 1/2 smaller. If our scale factor here happened to be, let's say, 4, scale factor of 4, all we would do is take that 4 and put it here where all the 0.5s are at. We would multiply then, and we'd have negative 4 times 4, negative 16. 4 times 4, 16. And our picture would be getting larger. Scale factor larger than 1, picture is getting larger. And we'd have a different triangle but much bigger. This centered at the origin thing is just telling us that the center is right here. So we're getting smaller right there instead of moving around the coordinate plane somewhere.